So you might as well grab a calculator. And to do the homework, you're gonna, we'll use a lot of class time like we have been doing. Um, I've been giving you guys quite a bit of class time actually, right, to do your homework. If you do your homework at home and you don't have a graphing calculator, please fill out the Google form for the TI emulator on Google Classroom. Okay, I got a link on there, right? I think you put it up.
It's pretty much just a free calculator that you guys can use online. It's the equivalent to what you guys have right there, the yellow one. But say you want to do this at home for whatever reason, get out of your chores. Um, that's what that emulator is.
Yeah, and I'll make sure I put it on Google Classroom. So we're gonna we're gonna do mathematical modeling using the quadratic function. Okay, and that's why I've been spending so much time on review for quadratics and factoring and all that other fun stuff because it's really going to come into play now when we put it to real life situations. All right. Let's look at the first problem. An object's height launched on Earth can be modeled by the following function. A lot of these problems are going to be, a parabola opening downwards. Okay. An object's height being launched on Earth. Well, if you think about it, here's our x and y axis, so it's going to be an object being launched coming back down. So most of these problems are going to be a parabola opening downward. All right, we use a function h equals negative 16t squared plus v naught. Now you could call that v zero or v sub zero. When I learned it, it was v sub zero, and then like the younger generation they use v naught and h naught. Okay, plus h of zero. Well, let's define some of these. The h on the left hand side here, well, that's defined as the current height. Okay, that's the current height, and if you notice, that's what we're going to be solving for this first section here. Now, like I said, when we get into a little more difficult real life problems, this class is going to be solving for the different terms. Maybe they'll be solving for v naught or h of zero, or so we'll have to manipulate the equation before we even start the problem. All right, the t. Well, that's pretty easy. The t's usually always stands for time, right? And in our problems, the time is measured in seconds unless otherwise stated. V sub zero is our velocity. It's our initial velocity, our starting velocity. And h of zero is our initial height, our starting height. Okay. Um, do we have any physics people in here? Did you guys, anybody take a lot of physics or in the science field and feel good about it? This negative 16 coefficient, by the way, what does this look like? What what does this equation look like um, when we were doing the three different forms, graphing the quadratic function? We had three different forms. Which ones does this look like? The standard form, right? Y equals ax squared plus bx plus c, right? where A, B, and C were the coefficients. Well, this, because we're doing an object's height being launched to Earth, and then it comes back down to Earth. What do we have on Earth that a, that's a force pulling it down? Gravity, right? That negative 16 represents gravity. Gravity. That's what that negative 16 stands for. Just like if we had the constant E equals mc squared that Newton came up with, the C was always a constant. That's just a constant that you multiply. The 16 means that force of gravity, it's the acceleration of gravity, is what it is. It means that it's going at a force of 16 feet per second squared. Force of gravity is, because it's coming down, negative 16 feet per second squared. That's the constant. Now, the physics majors or the physics people in this class probably don't recognize negative 16 feet per second as a force of gravity because everywhere else in the world except the US uses metric system, right? In the metric system, the force is minus 9.8 meters per second squared. So if you took a physics class, you probably worked with the negative 9.8. We crazy people in America like the standard system because it's harder. I don't know. I'm making that up. All right. Anything else? I know that this seems like a lot, but when we put it into action, it'll make more sense. So let's do a problem. A rocket is launched directly upward at 45 feet per second from a platform 70 feet high and is given by the equation the S of t equals negative 16 t squared plus 45 t plus 70. Okay, so there's a lot there. Let's decipher this. First of all, we don't have h here, we have the S of t. All right. Remember when we were working with this standard form of the equation, we swapped the y out with the f of x. That's all this is. Okay, it's just function notation. We swap the h out in this case with the s of t because the t is the variable in our equation. So also that s of t means it's function notation. Now I like to um, I like to always draw a picture. Okay, so I usually draw a picture of what's happening because it helps me decipher what all this stuff is going on. So I'm going to draw my y-axis and my x-axis. Okay. But I'm not going to use x and y. Notice that we have our height and our t, the time, right? The t is going to be our independent variable. So that's our x-axis. It's the time. Our height is going to be the y-axis. Okay, so that's my height. T and H are my axes. And if you want to, just to keep things straight, you can like say, hey, this is my x-axis and this is my y-axis. Because your calculator doesn't use H and T, it uses X and Y, right? All right, so let's read part of this problem and see what's happening with this flight, right? So it is launched directly upward I'm not even going to worry about the velocity right now. From a platform 70 feet high. So it's starting at 70 feet, right? So there's my height axis at 70 feet. It's launched and then it hits the ground, right? Okay. So I have somewhat of a pretty good picture of what's going on. And I'm going to go back here and answer some questions. All right. What is the initial velocity of the object when it is initially launched? Well, again, if we go back to our definitions here, we're looking for the initial velocity, which is v sub 0. V sub 0 is in the middle term, it's the coefficient of the middle term, right? It even says what it is. It's 45 feet per second. That's my initial velocity. So it's 45 feet. Now I'm going to use a slash mark that means feet. Two of them means inches. 45 feet per second. So I just answered A. A was pretty easy. B, what will be the object's maximum height? Well, if I look at my picture here, it launches from a platform, goes up, my velocity, and then reaches a certain height and speed, right, or time, and then it falls back down here to the ground. So this is actually the vertex of my parabola, right? That's the vertex of my parabola. But it's not x and y, it's t, comma, h. Okay, so this is my maximum height right there, and this is the time that it takes to get to that height. It's my vertex. So let's go ahead and figure out what this vertex is. So we need the vertex. Well, I need the vertex. Now, when we did graphing of the functions, we did it manually, right? We took our standard equation and we used the x coordinate of the vertex was negative b over 2a. Then we found that what the x coordinate was, and then once we found that, we plugged it back in there and found what y was, and then we got the point. But we're going to use our calculators. Okay? And it's going to be really nice to use our calculators for these problems. And why I have a different function in here is weird. I'm going to default everything back to normal here. Now, your calculator may already be set with the window and stuff. So I'm going to go try to clear everything out. All right, go to your y equals, clear it out, go to your zoom button and hit zoom standard and hit enter. Okay. Because you gotta know how to do this on your calculator. Okay. I want you guys to actually punch the numbers in while I'm doing it. Okay, so I'm gonna go ahead and put in my function, which is negative 16 squared. So y equals, use the negative key, not the minus key. Here's the negative key. I used the minus key once and it got a syntax error. So negative 16. Now we do have a t, but it's kind of a pain to get to. So I'm going to just use x. Negative 16x squared plus 45t. I'm going to use it at x and plus 70. Okay. Now hit your graph. And I have this wonderful partial parabola opening downward, right? Well, it would be nice if I could see that whole picture, right? So here's what I'm going to do. Your calculator defaults to x. It only shows from -10 to +10 for the x-axis, and +10 to -10 for the y-axis. Well, we know that it starts at 70 feet, so we know that it's going to be more than 10 feet for the height, right? So I'm going to go to my window, and I'm going to highlight the y max here. Okay, see how it's at 10. I know it's got to be at least 70 because that's my initial height, and it's even going to go up from there. Call me crazy, I'm going to put 200 in. Want to make sure I capture that whole parabola. So I'm going to go ahead and graph it, and there's my parabola. Okay. Notice that it starts right there, so that's where 70 is, right? And if I'm looking at quadrant one, that's the trajectory of my rocket. Huh? The hardest part is playing with this window to get your whole parabola to show up in the window. Okay. That can get tricky sometimes. And if you can't do it, just start out with really big numbers for your X max and Y max. It'll get there eventually. And then if you do it too much, well, maybe I don't want 200. Maybe I can go down to 150. You just got to play around with that window, okay? And it actually zoomed in a little better for me. Okay. All right. Any questions about the window and graphing so far? Now remember, my ultimate goal here is to get that vertex. Okay, I need that vertex. So now your calculator doesn't call it a vertex. Your calculator is either going to call it a maximum or a minimum. In this case, we have a maximum because our parabola is opening downward. So I have a maximum height. So I'm going to have to calculate it on my calculator. So I'm going to hit the second button. And then I'm going to hit the trace button because that brings up my calculations. Well, maybe not. Okay, calculate. And again, your calculator doesn't do vertex, it's using the maximum. Now, if my parabola opened upward, I would have to find the minimum. That's the vertex. But since it opens downward, I have to find the maximum. So I'm going to scroll to the maximum, hit enter. Okay. Do you see the cursor flashing there? All right, it's asking me, are you to the left of that vertex? Well, I am. I might even get a little closer. So if I'm to the left of that vertex, I'm going to hit enter. Then it's asking for the right bound. So if I get to the right of that vertex, anywhere, I'm going to hit enter. And then it's asking me, well, do you want me to tell you what that vertex location is? And I want to hit enter and say yes. And see how it went to the vertex? It's at 1.41, comma 101.64. So there's my vertex. Okay. 1.41, 101.64. This is my time, it's my T, and this is my H. So when I go to answer the questions here, what will be the object's maximum height? Well, it's going to be the H of the vertex, which is 101.64 feet. And the time it took to get there, 1.41 seconds. Okay. All right. Uh, so I got B and C. D, show the heights for the following times. Again, this is my T axis, and then this is my H axis, right? Or on your calculator, X and Y. Okay, so at 1 second, 2 seconds, 3 seconds. To get what the Y value is or the height, I'm going to go back to my calculator, and we've done this. I'm going to hit the second key. The graph key brings me up my table. And again, my time is X. So I need when X equal 1. So I'm going to scroll down here to 1. My height is going to be 99 feet. Okay. When my X is 2 or my time is 2 seconds, my height is going to be 96 feet. And then my time 3 seconds, my height's going to be 61 feet. All right. Now, I know that there's no question here, but you should analyze what's kind of going on here. At 1 second, I haven't reached my maximum height, right? So I haven't reached my maximum height. So this point, 1 comma 99, has to be on the upside somewhere, right? So maybe that's 199. 2 is after the maximum height. So 2 at 96. So it's already on its way down. And then 3 seconds, it's going to be below that platform. So that's what's happening with these points, right? It's just a rough idea of what's going on. Now, the next question is asking, well, what's this rate of change from 1 second to 3 seconds? What's this rate of change? Now, remember, parabolas don't have a constant slope, right? Rate of change is nothing more than slope. So I can't say it's one constant number. So what we have to do is consider all three of these points, 1, 2, and 3. At least that's what the question says, from 1 to 3, and take the average of the slope between the points. Remember what slope is, right? Slope equals the change of y divided by the change of x, or rise over run, right? Up or down over left or right. Well, in our problem, it's the change of height, the change of h, over the change, my x-axis is the change of time. Okay, so let's go ahead and compute this. The change in time is given from 1 to 3 seconds. So remember that y2 minus y1, x1 minus x2, whatever it is. Okay, that's what we're going to use here, except with t's. So I'm going to take 1 minus 3. Remember, the x's or t is on the bottom of our fraction. And our height, then from 1 second, is 99, minus the height for 3 seconds is 61. Okay, so 99 minus 61, 38. 1 minus 3 is negative 2. 38 divided by negative 2 is negative 19. and we're working with seconds per foot, right? So negative 19 seconds. I'm sorry, height is feet. So there should be feet, negative 19 feet per second. So that's our average rate that it's traveling. Isn't this fun stuff? No? Did I hear a no?
That was a squid answer.
Oh, I live for this stuff. Let's stop here and we'll continue tomorrow, okay?
Oh no. No more sheep.